Fascination water. No other natural element is so inspiring, mystical, destructive, and healing. At the same time, it's an indispensable source of our survival. Water is our basic nourishment, to which not all people have equal and secure access, and which is becoming more scarce. No wonder, of the 1,400 billion litres of water in our oceans, lakes and rivers, only 3% is fresh water. If our domestic bathtub were to contain all of this water, the water in this big glass would correspond to the freshwater fraction, while that in the smaller one would correspond to our drinking water reservoir. A precious good which has to be preserved by protecting water and the environment and by avoiding wastewater. Even in apparently water-rich countries such as Germany, the first harbingers of climate change are already recognizable. Dry summers and low precipitation winters have led to a drop in the groundwater table, especially in the northeastern part of Germany. Awareness raising aimed at a more conscious and responsible handling of water was needed. The avalanche was set in motion with the water meter. There's hardly a single household where a water meter is not installed, showing accurate drinking water consumption and urging its owner to save water. Dripping water taps are already a thing of the past. In spite of increasing luxury in the bathroom, an efficient handling of water has become a matter of course for the majority of Germans. The industry reacted hesitantly at the beginning, but later complied with the demand. By using different water-saving fittings, water as well as energy consumption can be reduced almost by half. Today, more homeowners and investors are becoming aware of this fact, and water-saving fittings are being already installed in new constructions or during the retrofitting of old buildings. Flow restrictors, which deliver only 3 litres per minute, will also achieve a similar effect in old fittings. This investment will pay off after just 1 month. Water can also be saved during toilet flushing and laundry activities. While washing machines consumed 160 to 180 litres of water in the past, they require less than 50 litres today. At the same time, water and wastewater costs have been increasing by twice as much as energy costs, an ongoing trend.
The share of the fixed costs for the infrastructure lies at about 80% of the drinking water and wastewater costs.
The largest share of costs will be needed for maintaining and rehabilitating the almost 100-year-old ailing supply networks, for drinking water and especially those for wastewater disposal lines. Experts estimate the rehabilitation demand for the coming years, especially for the sewerage system, at 50 to 60,000 million euros. This corresponds approximately to the value of the gold reserves in Germany's central bank, funds which many of the municipal water companies don't possess. Furthermore, these centralized systems are not flexible enough to deal with the rapid population change. In addition, there are problems related to incipient climate change. For example, more frequent precipitation has resulted in floods in recent years. On top of everything, an increasing number of torrential rain events invariably caused major problems to the German combined sewerage system, into which rainwater and wastewater flow together, so that a fraction of the rainwater-wastewater mixture flows untreated into rivers and lakes following heavy rain showers. Fish die as a result of oxygen depletion in water bodies due to bacterial decomposition of the wastewater components. Bathing sites and lakes often have to be shut down in summer due to high microbial load. On the other hand, exceptionally long dry periods hinder groundwater recharge and have fatal consequences on forestry and agriculture. Also in Germany, there are already regions with deficient amounts of water. Local authorities, planners, architects and engineers need to work together to implement new decentralized water concepts. These are more economical and, above all, more adaptable to climate and population fluctuations, closing eventually the water cycle. Rainwater can be simply utilized by means of evaporation or infiltration on site, relieving at the same time the strain on the municipal sewer. Green roofs in housing settlements in rural areas or in urban multi-story buildings offer excellent options for rainwater management. Various types of grass planted in the inner courtyards between paving stones instead of concrete surfaces are also suitable. Or even storage reservoirs which collect roof runoffs. Runoffs can also drain in constructed wetlands, as seen here in the middle of a city of 1 million, or upon heavy rain, runoffs can seep into the underground via an adjacent vegetated swale. Recently, scientists have continuously shown the high value of such measures for the microclimate, especially in large cities. The good old rainwater barrel has also been rediscovered as a water reservoir for the garden. Also, surface runoffs can be used directly to water the flower bed. On a larger scale, there are several modern technologies which can help to increase the rainwater potential. In Germany, about 50,000 to 60,000 rainwater systems are built yearly either from concrete or plastic, and the trend is upwards. The Darker family deliberately implemented rainwater utilization in its 3-generation house in Potsdam. Roof runoff drains directly into the 6,000-litre cistern. A storage capacity of about 700 to 800 litres is calculated per person. A filter, which is easy to clean, retains the coarse solids in rainwater. Rainwater is withdrawn from the cistern over a separate second network by means of an automatic control to the different floors for use in toilet flushing, laundry, and garden watering.
We have no concerns as to the presence of any residues in rainwater or whether it is not clean enough for laundry. During dry periods, we turn off the washing machine and use rainwater only for toilet flushing or to water the garden.
The Darker's rainwater system will pay for itself within 5 to 6 years. Eventually, a third of the yearly total drinking water and wastewater costs can be saved through rainwater utilization. For the Hamburg Hotel Ausspann, rainwater utilization has already paid off. The architect and hotel owner constructed a collection tank in a vacant room inside the building between the stairs and the guest rooms.
It works for 13 years, and we have already collected about 4,000 cubic meters of rainwater. We mainly use it to flush the toilets of 40 water closets connected to the system.
Great benefits have been achieved in other projects in Berlin, such as that of the Franciscan monastery, where laundry for the charity shop is washed with rainwater. This is profitable, since the wash water can be treated again and used for toilet flushing. This is the Weiberwirtschaft, a business complex for women in the center of Berlin. Here, 3 rainwater plants store up to 80% of the rainwater for use in toilet flushing in the different trades, including a tailor shop, glazier's workshop, and a restaurant.
These projects have achieved that the new effective technologies were developed and tested in Germany. We also developed guidelines for construction, planning, operations, and maintenance of these plants. Our technologies have also proved to be of value worldwide.
haben, die sich auch weltweit bewähren.
Another famous water-saving project is that of the Technology Center of the Fire Brigade in Hamburg. Rainwater from the flat roof flows through dam pipes into which filters are integrated and drains into plastic tanks placed in the cellar. From there, rainwater flows by means of centrifugal pumps into a washing plant. Here, all the fire hoses of the Hanseatic city are cleaned regularly. 4 fire hoses can be cleaned within 20 minutes, including drying and a pressure test. The yearly water bill of €13,000 uncovered the largest water consumer of the centre after a comprehensive examination. Up to 500 cubic metres of drinking water can be saved yearly through rainwater utilisation, thus reducing running costs. Even more rainwater can be collected from the roof of the Hamburg airport, which is stored in an underground reservoir at 12 metres below the surface, behind the central ventilation system. From there, rainwater is pumped to all airport toilets.
We feel ourselves committed to conserve these resources, and this has been the major driving force. And of course, after a rough calculation, it was clear to us that this would turn out to be profitable.
€22,000 can be saved yearly using rainwater. Therefore, in almost all modern large airports in Germany, these water reserves are being tapped. Also, renowned shopping centres are increasingly resorting to rainwater utilisation as a substitute for drinking water. A current example is Alexa of Sonai Sierra in Berlin, which is still under construction. The firm is internationally recognised as a specialist in shopping centres and owns 44 of them in Europe alone. It's also well known for its environmentally friendly design, operation and management. A short visit to the future rainwater reservoirs.
We are able to collect about 1,050 cubic meters of rainwater with the 2 reservoirs. We will primarily use this water for cooling to feed the air conditioning system, which we have installed in the shopping center.
The concrete basins will be eventually flooded. The stored rainwater is also connected to a sprinkler system and can be immediately used as reserve water for firefighting. The next rainwater reservoir holds almost 1.5 times more than that in the shopping centre's reservoirs, which happens to be the largest rainwater reservoir in Europe with a built-in sand trap. Rainwater falling on Berlin's Olympia Stadium flows largely from its highly corrugated roof surfaces into an underground reservoir, which is then used for irrigation of the sports fields and surrounding green space. On a hot summer day, about 120 cubic meters of irrigation water is needed, corresponding to about 15 to 25 litres per square metre. As such, lawn maintenance is a very sensitive issue, to be carried out by experts only.
Rainwater is a natural system, which is, of course, free of charge. It contains no chemicals and is distributed evenly on the plant.
Wassermenge auf die Pflanze und der ist absolut total sauber Wasser for the complete sports plant.
Several tens of thousands of euros are saved yearly at the Olympia Stadium in Berlin through rainwater harvesting. An evening bath, a delight for the two here. In their grandparents' and great-grandparents' time, this was only possible once a week at the most. A zinc tub filled with water in the kitchen had to suffice for the whole family. Today, Germans spend about 36%, that is over 1/3 of their drinking water needs, on their evening baths or shower fun. This is even possible without any bad conscience with regard to the environment or the family budget, as experienced here in Berlin-Spandau. In this 4-member household, everyone's allowed to shower as long as they wish, although wastewater is collected in a cesspool and later transported at high cost.
It is clear to us that we have to keep the generated wastewater volumes as low as possible. I can see it with our neighbors, who have to empty their cesspools twice as much as we do.
Water from the shower or bathtub flows over a separate second pipe network into the biological mechanical treatment system installed in the utility room. The grey water is treated in several stages. A special filter retains coarse material such as hair and lint. Bacteria which grow on the carrier material enhance the aerobic decomposition of the grey water components. The UV emitter gets rid of the rest of the germs, and clear water is made available for use.
I am always pleased to hear when water is being pumped from one compartment to the other. This is ready cash. I'll see what it looks like. If what isn't quality, wonderful. The water is not suitable for drinking purposes, but for toilet flushing it's adequate by all means.
This is also what the 30 inhabitants of the newly restored former fish smokehouse in the middle of Hamburg think.
We built a grey water recycling plant 20 years ago. It has been more like a do-it-yourself thing, and from today's perspective the maintenance expenditure was high. 5 years ago we installed this plant from the firm Pontus. This system requires little maintenance, but it is good to have a look at it now and then. We save €900 on drinking water costs, and this is a real success.
Researchers at different German universities have shown that recycled grey water is like rainwater, hygienically sound, and as such can be used for laundry. Due to the modular design, the single modules of the so-called AquaCycle can be varied depending on the amount of generated grey water. Larger systems are more profitable. Take, for example, the one seen in this cellar. With this system, 1,500 to 2,000 litres of shower water from 19 houses are treated daily. 800 recycling cabinets have been delivered to date by Pontos. 2/3 of them were delivered within Germany, and the remaining went to Western Europe, North Africa, Australia, and even to the Cape Verde Islands and the Maldives. Hamburg's municipal refuse disposal service has one of the largest grey water recycling plants in Germany. It treats the water from 32 showers and hand wash basins and stretches over 2 stories high. The principle of this large plant is similar to the smaller one for a one-family house.
We have a total capacity of 21,000 litres. The tanks for grey water treatment are found in the upper area. At the beginning, coarse filtration takes place. When grey water passes through the different stages, it is collected here. About 6,000 litres of surface water can be stored. The noise you hear in between comes from the pumps, which transport water either to the road sweepers found outside or to the toilet flushing tanks.
The road sweepers function properly without any problems. The nozzles do not clog, as is often the case with rainwater in which sand is trapped, or with well water which contains iron or manganese. Treated grey water from the showers is also used to dilute the de-icing salt solution for the winter road clearing services. The profit is just enormous.
After all, about 2 million litres of non-potable water are produced by this plant.
In this blockhouse in Berlin, the newest grey water recycling plant has just been completed in summer 2007 for the whole residential complex.
The existing water concepts from the 19th and 20th century are not able to solve the upcoming problems of the 21st century. The goal should be to produce as little wastewater as possible. This is achieved here with grey water recycling. Besides grey water from bath tubes, showers and washing machines, the more polluted grey water from kitchens is also treated for reuse in toilet flushing by 250 residents.
A very promising research project initiated by scientists and industry, whereby bacteria which settle on these foam cubes can proliferate vigorously. A backup system which may supply drinking water or rainwater through a separate network can be used to cover the demand when needed.
I am going to add some foot dye to our service water tank in order to test the pipe network systems and exclude any cross-connection. So let's see if all has been properly installed. I flush, and here the right water comes out. This is our service water. Now we move to the wash basin. Here no blue water should come out, neither on the warm nor on the cold tap side.
They've been seen in Hamburg for a long time, waterless urinals. Over 4,000 of them have been installed in public buildings in the last 10 years. Their principle goes back to a Vienna patent from 1885. The Senate Department of Environment helped foster acceptance of the system by promoting a new membrane technology.
This is a small tube which opens under the pressure of urine and closes when no water or liquid arises.
Through urine separation, Hamburg not only saves 22,000 cubic meters of drinking water a year.
Urine makes up only 1% of the total wastewater. However, it contains high-grade nutrients which cannot be collected in spite of modern wastewater treatment plants. Phosphates and nitrogen can still pollute the water bodies. We want to try to strike out in a new direction in sanitary engineering by extracting these contaminants beforehand.
At the Institute of Wastewater Management and Water Pollution Control at the Technical University of Hamburg, scientists are on the right track to win high-grade fertilizers using different technologies.
Today, there are several developments in many parts of the world on urine-separating toilets, where urine is collected and utilized immediately, as in the case in China with already 1 million installations. Basically, we want to build up an industry which produces a dry fertilizer from urine that will have high-quality standards.
In more housing developments in Germany, such as in Hamburg-Allermoor or here in Schöneichen near Berlin, residents already produce their own fertilizer for the garden by means of compost toilets. In addition to human excrement, kitchen and garden waste rustle 1 to 2 levels down the compost container where they undergo microbial decomposition. An exhaust pipe directly connected to the roof and boosted with a ventilator provides the required oxygen and ensures an odor-free operation. After 2 to 3 years, the finished compost can be removed, a rich brown soil which smells like forest earth. Most of the families were very enthusiastic about this ancient toilet principle for their modern houses.
When we bought the house, we were not aware of the presence of a compost toilet. At the beginning, I was a bit skeptical as to whether I get used to it. Today, I must say, I find it wonderful, and the benefits prevail.
Many families have been extremely creative and have decorated their draining pipes beautifully. Wastewaters from showers, washing machines and dishwashers are treated in a constructed wetland.
Wastewater is discharged through a pipe system in 2 stages. The first in the reed bed, which is seen here behind us. And after its passage through the gravel filter, the treated water is infiltrated in an infiltration ditch.
In spite of the high costs for the planted soil filter, including infiltration, such a decentralized disposal pays off after 5 to 6 years, since no wastewater is generated and less drinking water is consumed. Thus, it's an investment in the future. Such an investment was also profitable for the Lörs in Hamburg-Bergedorf. They constructed their house 10 years ago from a run-down greenhouse, with a compost toilet and a constructed wetland and no connection to the municipal sewer. The shabby greenhouse was converted into a blooming oasis. A successful experiment which is worth emulating in other areas in which greenhouses would otherwise cease to exist sooner or later. International trade fairs show it over and over again. The new decentralized technologies are fully developed. They offer large benefits even for countries with a still deficient water infrastructure due to their greater flexibility and lower costs compared to centralized systems. With its Zero-M project, the European Union promotes the implementation of these sustainable water concepts in the Mediterranean countries. With them, the worldwide upcoming water problems can be mitigated and the remaining resources conserved.